Hello, humans. So I thought we were going to be starting a lot later than we ended up being able to start. I'm currently getting shingles delivered. They told me it would occur between 7:30 in the morning and 5 p.m. and it shows right
Of course it
now.
does. Yeah,
Right
yeah, it
now.
always does. Of course it does. Yeah, this is the way it must happen. Is that I have somebody painting a busted sill in my house right now,
Uh-huh.
and he's coming in and out and using a vacuum cleaner. So yeah, no, this is you know this is just the way. Um, but he's a big fan of the show,
Oh, that's
strangely.
cool.
Yeah,
Very
yeah, yeah, yeah. So I told him,
strange.
yeah, I know. And so I told them that we're recording Astronomy because, oh, that's so great. I can't wait. Yeah, I'll be quiet. So at least my interrupter is a fan of what we do,
Yeah,
and
I
knows
I
and
don't know.
knows. Yeah, yeah, here you are, whatever.
Yeah,
Life's
this
a
is our
pain.
life.
Okay. Yeah. Let's so
Adulting is so weird.
yeah. It's funny. I think I was a good parent,
Uh-huh.
but I regret not forcing my children into uncomfortable adult type tasks when they were young, you
Talking to
know?
strangers on the phone and things like that.
Talking to strangers on the phone, yeah, troubleshooting a problem, getting a busted part fixed, dealing with warranty,
Yeah.
filing your taxes. These are the kinds of things that I think I would like to have a child have done for me. Just because nobody ever teaches you how to do any of this.
No.
It's always a pain, and it always requires a certain amount of just emotional fortitude to just go, okay, I can't let this problem fester anymore. I've got to deal with X. And
Canceling
then you
a
just
gym membership.
canceling a gym member. Yeah, exactly, right? And you're just like, I know I could, and the whole industry is designed to work on you just not having the will to force your way through this
Yeah.
thing. And so anyway, dealing with this kind of stuff is and yet this is adulting. This is part of the course. This is humanity.
Uh-huh.
And so I think if like I came across this idea, sort of my parenting philosophy is that like a lot of people say that, if they had difficult childhoods, then it created trauma, but also gave them lots of skills that they're then able to learn. And in many cases, it makes them better later on. And so the question is like, can you give a child that kind of a young childhood without the trauma?
Right,
Right.
right.
So that's the thing that you instead you provide them with hard jobs and coaching and you're watching their back. But yeah, they are booking their own uh taekwondo
Yeah.
uh you know sessions through the local community group, right? Like that's tough. And they have to go down and they have to bring your credit card and they have to pay for it. So that was one of the things that I actually did, and actually worked really well in the end. The kid was I got the email, I got the email that the thing was up for renewal, or they'd found out that the thing was up for renewal, and they went down to the community center and renewed it, and everything went great. And so, yeah, I wish I'd done more of that. So if you're a parent now with young children and you're wondering like, how do I strengthen my children without giving them trauma that they're gonna have to unpack with a therapist? You, you give them weird one-time adult type jobs so they can learn to adult, right?
Now,
Adulting.
one thing you did that I loved, because we got to travel enough together with your kids that I saw random shit,
Hmm.
is you would make your kids explain what advertisements were doing so that they could see through all the
Yeah.
propaganda. And I
Yeah.
just loved that. Like, and it wasn't just like straight up ads. You'd basically be like, "So why do you think they did this?" And so your
Hmm.
kids knew when they were being psychologically manipulated by the media. And this was like
Yeah.
before social media was what it is today. And it was, I still remember that, and it
Yeah.
was glorious.
Yeah, they're quite skeptical, which is good. And then the other thing is just when people are manipulating you.
Yeah.
So whenever I saw somebody acting manipulative, perhaps to me, and they saw it happen, we would talk
Yeah.
about it later on, just sort of like what is that? Oh, that's a guilt trip. Exactly. What's that? That is passive aggression. Perfect. Right. So, yeah, it's interesting. Those are the kinds of things that I wish, like I'm teaching my kids now how to invest. And it's really
Okay.
simple. You just invest in worldwide index funds, and you just take advantage of the entire market worldwide, and then you don't have to think about it ever again. Like it's done.
Yeah.
You've solved your retirement.
You
And
just have to
nobody
remember to
ever.
deposit money is the
Yeah,
catch.
you have to set aside 10% of your income. You put it
Yeah.
into whatever is the best tax type account that you have. You put it into a worldwide index fund that essentially captures the market of the entire planet, and then you just don't think about it ever again. You just keep adding to it over time, and it just builds with and so if your account goes to zero, that means that literally
The
human
whole world
society has
crashed.
failed. Yeah, and nobody ever explains this to me, and nobody ever explains to anybody. And so with my kids, I'm like, let's put a couple of $1,000s in your account. Now here's how you sign up. Here's how you do this every month. And now they're retiring. They're saving for their retirement, which is great. Like,
No
that's it.
20-year-old has done this in the past, and yet your 20-year-olds are doing this.
Exactly. Yeah. And I'm saying, like, if you do this,
Yeah.
then you'll be multimillionaires by the time you retire.
I have a friend who just retired, and yeah, it's because he had this lecture from his parents, and he
Mhm.
was an engineer, and compound interest is a thing.
Yeah, exactly.
So, yeah.
Yep. Okay. So anyway, let's do our job.
All right. So, hold on. I had to find my notebook that was hiding on my desk somewhere. And I am loving your new setup. I'm just going to keep saying that for a few
Hmm.
weeks because I continue to love your setup.
I'm just farther from the camera. That is the setup.
It brings me joy. Thank you,
I
Bill
know.
Nash, for the sub over on Twitch. And Veronica Cure, everything you said is entirely true. She was pointing out, make them sign up for getting an insurance quote. And
Nice.
yeah,
Yeah. Yeah. And then having to go through all of like, what's the square footage and what's the blah, blah, blah. And what's the manufacturer of the sprinkler system?
yeah.
Yes. Yeah, exactly. These are the jobs for children. And then you wash the dishes in front of them. Like you're like, okay, your sweet reward is I am going to do the most mundane tasks that you hate. I will clean your room and I will wash the dishes. And you get to just kick back in a easy chair and watch me do it.
I,
This is your sweet reward
I,
for learning to adult.
I love this. And one of my greatest failures as a manager is failing to make sure I always have one person on staff who doesn't mind cold calls.
Mm,
Yeah,
yes. That's a rough job that pays dividends.
yeah, yeah.
Yeah.
So, okay, we should do this thing.
Yeah.
I'm looking for that record button and I'm hitting that record button and I'm failing. There we go. Okay, we are now actually recording on my end.
Astronomy Cast, episode 727, the Parker Solar Probe. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. I'm really hoping we don't head into a government shutdown. I am really
Again?
yeah, we're heading towards that again.
Is this a thing again? Okay.
Yeah, yeah. I'm really hoping that Hera and Europa Clipper make it off the ground next month. And yeah, there's so much going on, and the next month we're gonna have so much stuff to share out. And I just want to say, if you're not subscribed to Escape Velocity Space News, which I put out, and you're not subscribed to all the things that Fraser puts out through Universe Today and on his Fraser Kane YouTube channel, you are going to be missing a ton of news. So go
Yeah.
subscribe to both.
Yeah. Of expected and unexpected news that is
Yeah.
coming down the pike. The sun. It's that ongoing thermonuclear explosion that's happening right over there. And although the sun is necessary for life on Earth, we still have questions. So NASA has sent the Parker Solar Probe to visit the sun up close to get us some answers. And we will talk about it in a second, but it's time for a break. And we're back. The Parker Solar Probe
Yes.
is one of like several spacecraft and ground-based observatories. The sun is really getting the business now. We're really focusing our efforts on the sun.
Well,
Um,
there's this little thing called Solar Max coming up, and it turned
yeah,
out a whole bunch of nations simultaneously got the realization we should be watching this. We should
we
see
should learn
what
more.
happens. And
Yeah,
so they're
yeah,
doing the
exactly.
thing.
Yeah. So let's talk about the Parker Solar Probe then. What is this spacecraft designed to do?
Its primary mission is to go into the sun's outer corona and try and understand why it's so hot from super up close. It's looking to measure the position, and it has succeeded in doing this, where the sun stops being the sun and starts being the solar wind. So there's this place where particles stop being directly connected to the sun through gravity and electromagnetic forces and actually fly free and out into space to cause beautiful things like the solar aurora that you'll probably be able to see tonight where you are in Canada. And I'm very
Yeah.
jealous,
Yeah,
by
we've
the
got a
way.
couple of announcements. Yeah, and we've got clear skies. We didn't have clear skies for the last couple of days, but we have clear skies tonight and probably for the next 3 or 4 nights. So, um, yeah, I mean, this mystery, this is one of the greatest
Yeah.
mysteries in solar astronomy, is that if you measure the surface of the sun, it is whatever, 5,800 Kelvin.
Mm-hmm.
And then if you just go out into space several 100,000 kilometers off the surface of the sun, the temperatures rise to millions of degrees.
Yeah.
And that's weird, right?
And
That hot gas that's in this sort of outer atmosphere around the sun is millions of degrees hotter than the surface. How is that possible?
well,
And yeah.
according to the second law of thermodynamics, it is not.
Yeah.
Heat should
Okay.
not flow from the cold place to the hot place. This is just to give you a sense of what's going on, like imagining a scenario where your light bulb is able to heat that hamburger what in whatever cheesy grill you've gone to a temperature hotter than the surface of the glass on the light bulb. That
Yeah.
hamburger does not exist. And so
Yes.
to explain what's going on, we have to look for some other means, some force that is moving stuff that is able to release energy. And it's that release of energy from something that must be doing the superheating.
Yeah. So the Parker Solar Probe was designed and built to try to answer this and other
Yeah.
questions in the solar environment. So now being close to the sun sounds dangerous.
It just might be. In fact, this mission has a 4.5-inch carbon foam core in its heat shield with two panels of reinforced carbon carbon composite on either side of that shield that
Wow.
is used to basically shield the mission every time it gets close to the sun. And one of the things it does that absolutely floors me is the mission has two different solar panel setups. And it uses the small one when it's getting super close to the sun, and it actually has to pull in its other one to keep it out of the sunlight because the sun is too powerful
Right.
for the solar panel.
Wow. It's like, I don't know, sunglasses. I'm not sure, but yeah, so it has a small set when it's close to
Yeah.
just deal with the intense light, and then when it's far enough away, it can then deploy its bigger panels. But even they are very small. When we think about, say, the Europa Clipper that has solar panels that are
Right.
20, 33 meters long, they are the size of like a football field. And the Parker Solar Probe is so close, it doesn't need a lot of solar panels. In fact, cooling is part of the issue. And so this trajectory that the Parker Solar Probe takes around the sun, this is special as well.
Yes. So the mission got taken off from Earth back in 2018. It launched in 2018. And it has made multiple rendezvous with the planet Venus, and it keeps changing its orbit to keep it essentially in a low key resonance with Venus, so it keeps re encountering the planet. And with each encounter with Venus, it gets a kick that allows it to get closer to the sun as it goes around and shortens its orbit. It's going to be making its seventh rendezvous this November, its final and its primary mission, and it's going to be 317 kilometers from the surface of Venus, which is
No,
it's
not, you may want to say that again. You said 317 kilometers, which is really close.
yes, and that's what it is. It's going to be 317 kilometers from the surface of Venus when it makes its
Oh, from Venus.
rendezvous.
Oh, sorry. Oh, sorry. I thought you were talking about the sun.
Yeah,
Yeah.
no, no,
Okay.
no,
All
no,
right.
no. That would be
Yeah. Yeah.
devastating.
Yeah. Why don't you say that again before I incorrectly edited you?
That's all right. So in November, it's going to be making its closest approach to Venus. It's going to reach just 317 kilometers from the surface of Venus, which is
Wow.
its other science target. It's absolutely amazing, and it's going to allow it to drop into an orbit that is just 6.9 million miles from the surface of the sun. It's going to be on an 88-day period, and
Right.
with every orbit, it is setting new fastest human moving object in the solar
Right.
system records. And we still so the next approach is going to be right after this episode comes out. So September 30th, it's going to be making its last approach on the current orbit. Then November 6th, it does this amazing flyby of Venus. And then it's on its final 5 trips around the sun in its primary mission. There's no reason to think it won't get extended.
Yeah.
But what I'm kind of loving is its final planned approach is on my birthday in 2025 on December 12th.
Oh, that's really cool. All right. We're going to talk about this some more, but it is time for another break. And we're back. Did I break the first time?
Yes, yes, you
Oh,
did.
well. Okay. All right. Um, sorry, Rich. Right. And so it's kind of amazing to me, and like this is just time accelerating, that as you say, it's been since 2018. It's
Yes.
done a ton of flybys, getting closer and closer already, and really it just has a handful left until it reaches the end of its primary mission. But as you said, it can last for a long time, and we should not anticipate that it's going to just screech to a halt at the end of the primary mission. It's going to keep on going, and as long as it's still in good condition, we'll get a lot more science out of it.
Yeah.
So let's talk about the science. So what has Parker Solar Probe helped us understand about that big mystery that we talked about at the beginning of the episode, and just like other mysteries in general?
So the Parker Solar Probe is named after Eugene Parker, who we're going to be talking about in detail in our next episode. And he is someone who postulated that nanoflares are what are transferring energy into the solar corona. Since then, we've also seen discussions of Alvin waves. And this is one of those episodes where I have to say I have read more solar science than I have listened to. So please be gentle if I'm mispronouncing this
Right.
word of many scary letters combined. So Parker Solar Probe has also looked at Alphon waves, and it has found the what's called Alphon surface of the sun, which is the point where energy being transmitted stops being associated with the sun and able to transfer energy back to the surface of the sun, and instead is part of the solar wind at that point. It was projected to be somewhere between 10 and 20 solar radii away from the surface. They found it at 18.8. It's always
Hmm.
great when things we think are true actually turn out to work
Yeah.
with the sun, which we are so wrong about so often.
And you mentioned nanoflares. So what are nanoflares?
So nanoflares are small points where, I mean, I'm holding my hand up as though that were realistic, but so we're used to seeing these massive flares that you can actually see in a 4-inch telescope in your backyard.
With
What
an appropriate solar filter.
with an appropriate solar filter or projected
Yep.
onto a piece of paper, pick one.
Yep.
Um, with nanoflares, you really need a spacecraft to be able to see them. They were able to see them with Parker Solar Probe, and these are smaller places where magnetic field lines are reconnecting and releasing energy when they do this. So the question becomes, in what way are waves propagating through solar magnetic fields able to release that energy into the solar corona? This is really what it's coming down to.
Right.
Alvin waves are where you have a magnetic field line that, for whatever reason, gets a wave propagating, and it's a standing wave, so it's moving in mass down the magnetic field line. As it propagates down, it's carrying energy with it, and it has the ability to release that energy into the outskirts.
Right.
Nanoflares are reconnections of field lines. All these different things, we're trying to figure out what is the dominant way of releasing energy out into the solar corona that allows that energy to not be heating lower levels.
Right.
Um,
Right.
yeah,
And is it like, is it end up being one or the other? Or is it really just looking like a mix of these various features on the surface of the sun that are contributing to this coronal heating?
we're still trying to figure out what the dominant cause is, but we do know it's a multi pronged answer. It's expected there's going to be one thing that is like the most big reason for this happening, the largest cause behind this heating. But what's interesting is like Parker isn't just finding things that we knew should exist, which is magnificent. That is so awesome for all the scientists whose work is getting proven true. It's also out there going, nope, this doesn't work. So one of the things that Parker Solar Probe discovered in its very first pass was there are switchbacks in the magnetic field lines of the sun where the lines literally coil back on themselves, making S shapes.
Wow.
And so Parker's flying through and it's able to detect all these wild switchbacks in the magnetic field. And there was this moment in time of how do these form? How does this work? And are they what's carrying this energy out? Well, it's been figured out that the way they appear to form is you have magnetic field lines that are rising up from the convection cells in the sun. And as those convection cells are doing their thing, motions in the convection cell can essentially whip these lines around, creating these switchbacks in the magnetic
Mm.
fields. But it appears, as of a paper back in July 2024, that there's not enough energy in these switchbacks to be what's heating the corona. So we have this super cool thing. It was super promising for a hot minute, and then it turned out that heat was insufficient to heat the solar corona.
Right. Right. It it's amazing that the sun is as complicated as it is. I mean, when you really just think about it, it is a blob
Yeah.
of hydrogen and helium with a few other metals mixed in, but they are a fraction of the hydrogen and the helium. It's held together by the mutual gravity of all of the stuff that's
Yeah.
there. And yet you get layers with the core and the radiative zone and the convective zone. You get blobs of material rising and falling like a lava lamp. You get these magnetic fields that get twisted up and switch places, polarity every 11 years. You
Mm-hmm.
get these nanoflares on the surface. You get the granules, which are the points where the convective blobs are rising up. These magnetic field lines twist and turn. You get sunspots, which are areas of relative cooler where the field lines are breaking through the
Radiating
surface
out.
of the sun, and then these things are are combining with waves passing, propagating down the magnetic field lines that are bunching up and heating up material in the solar atmosphere. And then this material is being driven energetically at, in some cases, hundreds of kilometers per second out into the solar system where it interacts and creates this bubble around the solar system. And it's not like there's external random inputs that are going
No.
into this. I mean, when you think about, I don't know, just like most stuff, like even orbits, like say orbits of the moon around the Earth, like the tides come because of this weird interaction,
Yeah.
but the gravitational interaction between the Earth and the moon. And if the moon didn't exist, then we wouldn't have tides. And if we had a bigger moon or the moon was closer, we'd have different tides. And the ground would be heaving. And if it got too close, it would break up. Like all these interactions. But the
Yeah.
sun is just a blob, just sitting there doing its thing.
Yep.
And yet it leads to all of this complicated emergent process that has baffled astronomers for a century.
And we keep
And
finding new ways that it's complicated. So, like, the Voyager probes have finally both made it past the heliopause. They have left that
yeah,
outer bubble. But then Parker Solar Probe discovered a new inner bubble where the first 3.5 million miles or 5.6 million kilometers from the sun is a no dust zone because the sun, its radiative powers have blasted out of existence any dust that tried to exist in that inner layer. So now we know that there's this inner sphere that is dust free thanks to the sun's heat and power. We know that there's the inner parts of our solar system that are safe from a whole lot of cosmic rays that would otherwise be bombarding us. And so we just keep encountering these different transition zones in what the sun is able to do as it influences its environment.
yeah. All right, we're going to rave enthusiastically about the Parker Solar Probe and the sun
Or
some
Venus.
more, or Venus, but it's time for another break. And we're back. All right, you mentioned Venus.
Yes.
So, what has Parker taught us about Venus?
That it can actually be seen from outer space. Like its surface can be seen from outer space. This was one of those things that was just like, how? That can't be possible. What are you talking about when I read about
Right.
it? It turns out the surface of Venus is so hot that it radiates light in the furthest red of visual and the nearest infrared light. And the Parker Solar Probe has, on multiple passes now, used its wide field camera to observe the nighttime side of Venus, and it can make out the geology of the surface and what temperatures are being radiated,
Wow.
and the geography of the surface by being able to make out where the plateaus and the plains are. And what's amazing is seeing these visual light nighttime because the planet is glowing images side by side with the Magellan radar images, and it's like, oh, I can match these up. I am actually looking through the clouds.
Yeah.
It's a hot world. It's a very, very hot world.
It is amazing. When we think about the images of Venus, we're very familiar with that orange ball
Yeah,
picture that has been, and that was taken by the Magellan
that was
spacecraft.
radar.
But with radar, right? And so that's not like the real color. The spacecraft was equipped with a radar system. It was sending pulses down, watching as the pulses bounced off
Yeah,
the surface of the, and back up to the spacecraft, and it detected the distances, and they were able to measure with pretty low resolution
yeah,
the surface features. Like I think they're down to like a kilometer
yeah. That's about
per
right. It depends
pixel
on
or
where
something.
on the
Like
surface it is.
yeah,
Yeah,
yeah. And so they don't know a lot about the surface of Venus. And that's it. As you said, no other, we can't detect the surface from Earth. We can't detect the surface with the various Mariner spacecraft, all of the Venera probes that felt like it was only when they got down to the surface could they actually see the surface. Until then, it had been this mystery. It wasn't until Magellan told us that a surface even existed at any, at any kind of
yeah.
resolution. And yet here is Parker Solar Probe with this not being its primary objective, passing by and going like, "Oh, look, I can see mountains." Moving
And
on.
to be fair, most missions that were flybys were like, we shall look at the daytime side. And that was their mistake. It turns out you need to be
Right.
looking at the nighttime side. And
Yeah.
it's it's just one of those things that is truly flooring. And of course it's looked at Venus's plasma tail and helped us map out the plasma tail. And one of my other, to switch topics to another planetary object, one of my other favorite results is Parker Solar Probe has on board equipment to measure electrons, protons, and alpha particles, helium ions. It has on board dust detectors. And because it can detect all these different particles, they used it to try and figure out the cause of the Geminid meteor shower. And this meteor shower, which occurs every December, again when my birthday is,
Yeah. And
that's
it's the best one.
it's the best one.
Yeah.
And it's caused by an asteroid, which is not what is supposed to cause meteor showers. And so the question has always been, is this asteroid actually just a dead comet core that's on an inner solar system orbit somehow? And by looking at the kinds of particles and the speeds of the particles involved, they were able to compare several different models to figure out what kind of activity would have jettisoned those particles, creating the observed meteor shower. And they figured out something violent happened to the asteroid. It wasn't just like a comet outburst. It was an asteroid got hit, probably by something else, probably a smaller asteroid, and
Mm,
that collision, that violence, is what generated the particles that cause every December the Geminid meteor shower.
that's really
Yeah,
cool. Um, so how is the spacecraft doing? I mean, I
it's
think
fine.
it's in near the sun, like flying through the
Yeah,
upper atmosphere of the sun. And how's it doing? It's good. You
yeah.
know, nothing weird, nothing, no big disasters have happened.
My only concern for the mission is the current NASA budget, because
Mm,
there is currently a lack of funding and a mandate to go to the moon, and the Artemis program is the great vacuum in the administration at the moment. But as long as they can keep going, the latest National Academies study that came out last week really gives me some hope, because it called out NASA for apparently 83% of NASA's infrastructure has outlived its predicted lifetime, and at some point that will catch up to NASA.
right.
So there was a call to look to the future, to plan for the future. So I am hoping that part of that plan will include, let's keep LRO going as long as we can. Let's keep MRO going as far long as we can, and let's keep missions like Parker Solar Probe, Solar Dynamic Orbiter, SOHO, looking at the sun, helping us stay safe, and working with us to understand solar weather.
Yeah, it is kind of ironic
Yeah.
that NASA overbuilds and does such a good job, a careful job with the missions that it builds, that they last a lot longer than the original mission was intended. And so that requires ongoing maintenance and teams to communicate and time on the Deep Space Network.
Yeah.
And and we saw, for example, that they're shutting down Chandra,
Yeah.
not because it's failing, but just because
Money.
they don't have the maintenance budget to be able to maintain the spacecraft.
And Hubble's
That's
looking at
bonkers.
some major cuts. And
Mm,
so the question becomes, what does Congress allow to happen, though? This is the other thing that
yeah.
everyone's keeping an eye on, because while NASA can express their desires to cancel programs, mission's not over until Congress deallocates its funds.
Yeah.
And so right now there's notes coming from congressional committees that just might provide the grace needed to keep Viper going and to keep Chandra and Hubble going. Chandra was given a brief reprieve. We get to see how long it keeps that reprieve.
Do we know what the final stage for Parker will be? I mean, I love the idea of them continuing to test out its resilience. Like maybe when they're finally right at the end, they go, well, let's see how close to the sun we can get. before we die.
So it would have to have additional Venus encounters, get
Mm,
those more gravitational assists to get it out of its current 88-day orbit. That's not impossible. I don't know what mission planners have done that is the unofficial, at this point, future of the mission, should it be granted a continuing chance. But yeah, in order to get even closer to the sun, it will need to meet up with its good friend Venus.
yeah, right, right. But then, with a couple more flybys, who knows how close we could get. I mean, a couple of million kilometers above the I would love, just as, we saw the end of Galileo going into Jupiter. We saw the end of Cassino going into Saturn. I would
Yeah,
love to see the end of Parker going into the sun, but that's just me.
it's
It's the
always,
hardest place to reach in the solar system,
it really
and it would show,
is.
yeah,
It's
yeah, it
much
would show our
easier to
technology.
fling your enemies out of the solar system than to fling them into the sun. Just saying.
Yeah, yeah, yeah. When people ever say like, "Oh, we should just throw our garbage into the sun," like
No,
that's the hardest place to reach in the solar system. You're just kind of like saying, "Why don't we, throw our garbage to the on the top, put our garbage on the tops of mountains?"
yeah, please
It's
don't.
really hard. Yeah, don't. That's Mount Everest. That's how we got Mount Everest.
Yeah,
Anyway,
yeah,
well, it's so cool, and I doubt this is the last conversation we're going to have about the Parker Solar Probe.
yeah.
There is so much science to be done, so many amazing discoveries, and it is doing great. And so hopefully we will do a follow on in a couple of years and just give you, because we are all still in the middle of this time and we just don't know all the answers about how the sun works.
It's true. And
Yeah,
that's one of the most amazing things is we have a star right next door, and it is still a mystery that we are learning about.
yeah. Thanks, Pamela.
And thank you, Fraser. And thank you so much to everyone out there at every level in our Patreon community. This week, we are going to thank on air our $10 and up patrons, Adam Anise Brown, Andrew Palestra, Astro Bob, Bebop Apocalypse, Bob Zatsky, Brian Cagle, Cami Ressian, Cooper, David, Dean, Dwight Ilk, Father Prax, Frodo Tannenbaugh. Oh, wow, you tried to give me pronunciations and I didn't see them fast enough. Sorry. Gerhard Schweitzer, Greg Davis, Harold Bardenhagen, Jarvis Earl, Jeff Huna Mortar. Welcome, you're new. Your name is scary. Jim Schooler, John Drake, J.P. Sullivan, Katie Byrne, Kim Barron, Kensaya Pinflienko, Lee Harborn, Mark Schneider, Matthew Horstman, Michael Hartford, Michelle Cullen, Noah Albertson, Pauline Middlelink, Robert Cordova, Ruben McCarthy, Scott Briggs, Zeki Kemler, Stephen Coffey, Thomas Gazetta, Tushar Nakini, Zero Chill, Alex Cohen, Andrew Stevenson, Astro Sets, Benjamin Carrier. And I've started going into next week's name, so I'm going to stop there.
All right.
Thank you all so very much. You make this show possible, and it's why our podcast sounds so much better than our live version. Thank you.
Yeah, yeah. Thanks, everyone. We'll see you next week.
Bye bye. And then they
And then I
say,
saved.
I I was going through and looking something up in one of our old episodes, and one of the questions asked was if Fraser ever inserts names into the list just to mess with me. And the answer is no, no, he doesn't. I
No, he's
sometimes wonder if some of our patrons do. Um,
absolutely.
and
Yeah,
yeah, I am what happens when you learn to read more than you hear things and never learn phonics in school.
yeah.
And I'm so sorry, everybody.
Yeah, the scooper McScoops a lot, right? For
Yes, I
example, like
love
people,
stuff like
people,
that.
yeah, people definitely put ridiculous, and it's funny because people will put in like their YouTube names will be ridiculous,
Yeah,
and I'll just read them with a straight face.
you have
Like,
to.
like, yeah, exactly. Like if you're going to make this your public persona, I'm going to acknowledge it. And I'm not gonna giggle about it. I'm just gonna straight facedly say your YouTube name and yeah, and move on. So um questions. Hit us with your
All
questions.
right, so
Unless you have perhaps a three body related television show that you have feedback to give me.
no, I still need to watch that. I'm sorry,
Yeah.
I was coding last week. I'll put it on this afternoon while I'm working on just some UI design stuff. I
Have you
did
played around with? Oh, go ahead.
I did attempt to start watching while not only watching the Savage Rain and determined it is
Scavenger Strain.
something,
Yep.
yeah, it requires 100% of your attention.
Yes. Yeah, you can't multitask watching
No.
Scavenger's Reign. You've got to watch it straight on. Yeah.
Yeah, so I will be
And pause and
rewatching.
go back and like,
Yeah.
wait, what? What just
Yeah.
happened there?
Yeah.
Yeah. Yep.
The Terminator Zero is one that is actually pretty good that just came out. It's an anime version of Terminator.
Yeah, we've been
It's
watching that. We're about halfway through. I'm not a huge fan.
I said pretty good. I didn't say
Yeah.
great.
Yeah.
Um, it has interesting ideas in it. Existential Squee says that hard hit to the sun blows my mind. Wouldn't it be easier to throw something down a gravity well? So the problem is you will often end up throwing it into a orbit around the
Hmm.
sun, and the question is, how do you get rid of the angular momentum so that it actually falls the rest of the way into the sun?
Yeah. Yeah. So the here on Earth, we are traveling around the sun at 30 kilometers per second. We have this angular momentum around the sun. And that the only way to get to the sun is you have to cancel out 30 kilometers per second of momentum. There's no other way to do this. And so, people think, well, if you just throw something at the sun, then it's going to go towards the sun, but it's not. It's kind of like if you're driving down a highway and you throw something out the side of your car,
Yeah.
an apple core, whatever. Um, the yeah, the wind will slow it down, but there's no wind in space, and so
Yeah.
the apple core starts. It's going the same highway speed as you're going down the road, and same thing. If you throw something off the Earth towards the sun, it will continue to orbit around the sun just like the Earth. It'll be on a slightly different orbit
Yeah.
depending on how much of a change of velocity that you give to it. It's only when you have accumulated a complete and total 30 kilometers per second of delta V of change in velocity that you actually reach the sun.
Hmm.
And the delta V required to go to Mars is like 8 or 5 or something like that. Delta V
Yeah.
to leave the solar system from the Earth's orbit is about 16 kilometers per second. So it's so much bigger.
There is a very cool video kicking around that Instagram decided I needed to see of someone bike riding a stunt course on the back of a moving train. And what's cool is because they have the camera set up at a railroad crossing, you can see the bike's motion relative to both the train and the ground. And the
Mm,
bicyclist is mostly staying in place relative to the ground and is doing all of these tricks that require significant velocity, but that velocity is relative to the train, not relative to the ground. And it's this really cool lesson in moving frames and stuff like that that I just haven't seen before.
yeah. Yeah, that's amazing. Um, Zepan asks, how's it going with the probe that it's going to observe over the poles of the sun? So that's the solar orbiter.
Yes,
It's fine.
it's
Is
fine.
that another episode?
It's not going into the kind of orbit. So way back earlier in the 2000s, the plan was that Parker Solar Probe, that at that point was the Solar Probe Plus mission, would have a much longer orbit that would fling it out by Jupiter that would be used to tilt its inclination to put it into a true polar orbit.
Yeah.
That mission, along with a couple of other outer planet missions, all got canceled under the Bush administration. So we got left with our inclined 3 degrees to the sun Parker Solar Probe. The Hinod mission was
Hino
looking.
day. Hino day.
Hino Day mission.
Yeah.
Again, I read things. The Hino Day
Yeah.
mission um, is in a polar orbit that started out inclined, I think, 24 degrees to the equator and is going to get inclined 30 something degrees to the equator. So it's not truly a polar orbit, but it's allowing us to see further than we've ever seen before. And if you think about it, 30 plus 90, which gives you
Yeah.
the field of view, does allow you to see over the pole of the sun. It's just not looking down on the pole of the sun like one might wish for.
So solar orbiter is going to get to 25 degrees, which is
Hmm.
the European Space Agency's
Right.
mission.
And then in its
And
extended mission, it's supposed to go to 30 something.
And with that's right, with additional Venus flybys, it could get to 34 degrees.
Yeah.
And who knows? Like that's the extended mission. Who knows if it just keeps going? But that's a long way from 90 degrees. Now, there was one mission that was measuring the poles of the sun. That was the Ulysses spacecraft back in the
Yes.
90s, but it didn't have a camera.
Yeah.
So it's amazing to think that the poles of the sun have never been photographed,
Yeah.
just ever.
So Veronica Cure over on Twitch asks, Voyagers had to do so much to get going fast enough to leave the solar system. Would we be able to do that easier today? Yes, the New Horizons mission is its demonstration of that. They haven't got there yet, but it will be going faster.
No, it won't.
It won't? I thought it was.
No, no. Voyager 1 is the fastest spacecraft that humanity has ever sent
Why did
out
I
of the
think that
solar system.
Parker was
And it's
going the
still going to be faster
fastest?
than Parker is the
Not
fastest.
Parker, sorry. New Horizons. Was it fastest at some point and then dropped speed?
Maybe,
Okay.
but yeah, no. So it doesn't have the same escaping velocity that Voyager 1 does. So Voyager 1 is continuing to make more ground than New Horizons. And there's really only New Horizons, Voyager 1 and 2 that are the only three spacecraft on escape velocities. They're still functional right now. I mean, the Pioneers are, but they're dead. And the Parker Solar Probe, when it goes through its aphelion, it is the fastest spacecraft that humanity has ever built. And then it goes out to perihelion, and then it's not anymore.
So, New
Um,
Horizons was launched in 2006 with the fastest launch speed. That's what confused me.
yes, yeah, but it
So,
had less. It only had one gravitational assist. It only used Jupiter.
yeah.
It didn't
Yeah.
use Saturn. It didn't use Uranus and Neptune the way Voyager 2 did.
My bad. Thank you.
Um, Raj Luther is asking, will there be plans for a Parker Solar Probe 2? The reparkening.
Yeah,
I've,
so no, not so much. Um
I mean,
Money is so
there's
tight
always a
right
huge
now.
collection of proposed solar missions
Yeah.
that live in this solar missionosphere,
Yeah.
and that people will bring out and discuss at various conferences, and they'll provide updates and they'll tweak their math, and they're always looking to make their mission more appropriate for the needs and the demands of the scientific community. And eventually something crosses the finish line and actually becomes a real proper mission. But right now, I
Right
don't.
now,
I mean,
NASA has said that their primary goal is maintaining missions
yeah,
that are flight ready. So, like,
yeah.
Europa Clipper isn't in danger, but, and things already launched aren't so much in danger, but everything else can count its days as possibly being numbered.
And then Roger Luther also asked, can the knowledge gained from the Parker Solar Probe help develop fusion reactors?
No,
No.
no.
I mean, like, I'm sure understanding magnetic fields, what is it?
Magnetohydrodynamics, except what
Hydrodynamics.
they're not looking at magnetic confinement as much as they're looking at
Yeah,
magnetic field structures in convective environments, and
right.
we're not building magnetically confined convection environments.
But watching how plasma moves along magnetic fields and interacts and heats up with in the solar corona, like I'm sure a lot of this is applicable, but the heart of it is that the sun produces its fusion through its mass
Yeah,
crunching down at the center of the sun,
yeah,
creating this level of pressure and mass. But the temperature is relatively cool
yeah.
compared to
The
a fusion
corona.
reactor. They have to get they have to increase the temperature to make up for the lack of pressure that they can do to produce fusion. So really, at the end of the day, they're vastly different
Yeah.
processes. I love that like the hottest place in the universe might be in a fusion reactor here on Earth,
It's true.
right?
It's true.
Yeah. And the coldest place in the universe is almost certainly on Earth.
Yes, because we keep making them in laboratories.
Yeah. Um, but not like the fastest moving particles. We still can't match what
No,
supernovae can do.
no, we cannot.
Are there any more questions over on Twitch?
Um, there's a cool comment. Veronica comments, Voyager 1, 2, and New Horizons are our ambassadors. And
Yeah,
yes, I saw
yeah.
something scary. Star Trek motion picture is 25 years old. No,
No,
it's
not
50,
25. It's
it's sorry,
gonna
it's
be,
from 79. So 70,
yeah.
35 years old.
No,
I'm still not mathing.
20,
Good lord.
yeah.
I'm
Yeah,
in so many
25 plus
layers of
45?
I'm in denial.
45 years old.
Yeah.
Yeah.
Yeah, watch how
Um,
much I can't math when my own age is being shown. It's 45.
yeah.
Star Trek
Yeah.
the Motion Picture is 45 years old and William
Yeah.
Shatner is still around. Um
Yeah.
yeah.
Um, so we did the summer hiatus question shows. I
Yeah.
kept running my question shows over the summer. And so, people ask like pretty weird questions. And someone asked me in one of the episodes, could we go and bring the Voyagers back home? And I answered it, and people were mad. Like, well, that's clickbait. Like
But
obviously it's
someone
not a good
asked.
idea. Yeah, someone asked the question, and that like if a person asks the question, it means that they don't understand the orbital mechanics, the how difficult it is to bring something back. But a thing that I had failed to bring up was just to reference the V'ger in Star Trek: The Motion
Yes.
Picture,
Yes.
and also that idea that the Voyagers are ambassadors.
Yeah.
Why would we bring
Our
them
ambassadors
back?
home with the gold
We
plate
sent
and
them,
all the effort
yeah,
and everything else.
yeah, we sent them out to visit the universe. So we don't need to bring them home. But um, but yeah. Any other questions? Anywhere?
Nope.
Anyone?
Although
Anyone?
null denominator is commenting that the entirety of the 90s was still only 10 years ago, and I have to agree.
The entirety of the 90s was 10 years ago? What?
It's a joke.
Oh,
It's
I
the
see.
yeah.
Like it feels like the 90s just happened?
Or it's just the like mental history of when did things happen. Like
Mhm.
internally I am not as old as I actually am,
Yeah,
and
totally.
therefore I keep being deeply confused when things like appeared a I remember my grandma being that age number of years ago.
Yeah.
Yeah.
Do you do that? I
Yes.
will like watch a television show, an older show, a movie with an older actor,
Uh-huh.
and then I'll like Butch Cassidy and the Sundance Kid, and you're watching it in the 1960s,
Yeah.
and and he's 33, and you're
Yeah.
like, God, oh no. And then you
Uh-huh.
watch, yeah, someone who is in their early 50s in the TV show. I'm like, I'm his age,
Uh-huh.
right? When he shot that movie.
Uh-huh.
Or I'm way older when he shot this famous person who's now seen as very old. I was, you know, like I'm older than Anthony Hopkins was when he was in Silence of the Lambs, right? He's like, oh my God, so old.
The cast of Friends is now older than the cast of Golden Girls was when they filmed.
Yeah, exactly. That kind of thing.
Yeah.
Yeah, yeah, yeah. And I sort of do this mental check where you're for a while there, I'm like, I'm the youngest person in the room. I'm the
Yeah.
young now I'm not the youngest person in the room.
So
I
the
might
weird
be the
thing
oldest person
about
in
the
the room.
field that I'm in is going to astronomy conferences and planetary science conferences. The
Yeah.
Apollo generation refuses to retire and
Right.
is
Yeah, I'm still the
long.
youngest person in the room.
Right.
Yeah.
It's just like what the hell happened? So there's like all the babies, all the people who have just finished their PhDs. And then there's this gap because there's
Yeah.
no jobs. And then there's like a few of us Gen Xers going, we're still here. We're still here. And
Yeah.
then the Apollo generation just they're going to die in those jobs or they're
Sure.
going to all retire after the first Artemis landing. I think they're all going to retire after the first Artemis landing.
Watch the Fall Guy
No, I
on.
haven't.
Yeah, it's on Prime. and it was good. It was, the stunts were just unbelievable. It was absolutely um like a love letter to the stunt industry because
Okay.
they just did ridiculous stunts and they did them all practically. Like they did as
Yeah.
many of them as they could, just just all out. Um, and that was a TV show back in the 80s
Okay.
with the guy who was the $6 million man.
Oh,
Forget his
that's
name.
right.
Yeah, and then he was the fall guy where he was a stunt man, but he had various episodes where he was
Solving
helping solve crimes,
mysteries.
and
Yeah.
yeah, exactly, yeah, yeah,
As
and so
stuntmen do every day.
right, 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 and there are some cameos, and you're just like, wait, these people are still alive?
Yeah.
Wait, am am I older than them? So, yeah, yeah, I'm not, but it's in some cases it's not that much far apart. But anyway, yeah, good movie. I liked it. Actually, a movie that we watched that I didn't realize what it was. So there's
Hmm.
a movie on Netflix called The Hitman,
Oh, okay.
and we watched this last night, and it was really good. It's a Richard Linklater movie.
Hmm.
He did Dazed and Confused. He did uh oh man, the Philip K. Dick movie
Electronic
about
sheep.
no, not Do Android's Dream, but the other one. People are going to mention in the chat. But anyway,
Postman.
no, no. But I really like Linklater. I
Okay.
had never watched Dazed and Confused until like 6 months ago, and had been sort of sitting on
Oh,
my watch list, and I finally watched it, and I loved
yeah.
it.
It's
I just
fabulous.
loved it. Yeah,
Yeah.
Carla was like, "Nah, I don't, I'm not a big fan of this," and it just captured being a stupid teenager
Yeah.
post graduation in
Yeah.
such a beautiful way.
I love
And
it.
I've watched a bunch of his stuff, and I love his his directing style. So anyway, um, uh, yeah. Anyway, so if you're looking for a movie, the Hitman, it's surprisingly good. Like it looks weird, and you think it's like some kind of weird
It's one I meant to see, but
romance.
I didn't get a chance to.
Yeah,
Yeah.
yeah, yeah. And the gist is that it's about a high school teacher or college teacher who does some freelance work for the police, and it's based on a true story. And it
Okay.
turns out he's a really good in fake hitman, and he helps them sort of catch people who are trying to conspire to murder their friends, coworkers, partners, children, mothers, etc. And how complicated it turns into. So yeah, it was actually a really good movie.
I saw Beetlejuice last night, and it's
That's
like
the
the
sequel.
yeah, and
Mm.
like it was good. It was good. It was terrible.
Oh no.
And it was just like, I don't know if you've ever been in a movie and been like, I should have got up and left 5 minutes ago and I would have loved this movie. And I did not do that. And now I have regrets.
Yes.
And
That's a baller move to go. I've had enough. I don't want to watch any more of this movie. Going out and getting your money back.
yeah,
But it works. You can do it. People will do it.
I have a season pass to the Alamo Draft House. So they
Mm.
have my money no matter what. But
That's
yeah,
cool. How much does the season pass cost you?
it's like 20 something a month. And we go to 3 or 4 different movies, and they have older movies that like we got to see all sorts of things on the big screen that I remember seeing when I was a little kid.
Yeah.
And it's just cool to get to see the older movies and all the stuff that just came out, and they have a pub, so I yeah, it just brings me joy.
Yeah. That's
And
great.
they have what they call a 4D theater. It's one with like a killer sound system. And yeah, so I have started going to a lot of movies and
Well, that's great.
regret what I did last night greatly.
Right. Right. All right. Well, we've reached the end of our hour. So thank you everyone for hanging out with us. Thanks, Pamela, as always, for bringing the sweet knowledge. Um, Thank you in advance to Rich and the various
Yes,
people who are going to have to edit this nonsense. We're sorry.
we're
We'll try
sorry.
better. All right. Thanks, everyone. And we'll see you next week.
Bye bye.